Hello, AP students. This is Mrs. Politsky, and I have notes for Chapter 8, Emotion and Motivation, in the second part, where emotions come from. So, as we go along here, fill in what you need. Where do our emotions come from? Well, there's some neuroscience that goes along with emotions, and we kind of have to take a look at the emotional processing system. For the most part, we have kind of a fast response and a conscious response. So when we talk about the fast response, this operates mainly at an unconscious level where it quickly screens incoming stimuli and helps us respond quickly to cues of potentially important events before they reach our consciousness. And this could be like our early warning defense system. Because it has that ability to be linked to our implicit memory before it even reaches our consciousness. There's also conscious processing, which is kind of stemming from the fear that grows in our mind when you anticipate a stressful or fearful event, like giving a speech, because it's linked to our explicit memory. Explicit memory are those things that we're really aware of when we purposely remember. Got to remember, our brain really doesn't have an exact emotion center. Instead, we've got emotion related circuits that serve the two distinct emotion systems. And this can complicate matters. These two systems interact. So the feelings that we associate with an emotion, such as fear, can well up into our consciousness from our unconscious system. So conscious emotional systems can signal unconscious circuits, which produce the knot in your stomach just before giving a speech. And the interplay of these two systems apparently gives rise to feelings that we call intuition. So along with that, we're going to talk about where some of these emotions are coming from. And yeah, there is a little biological side to this, and we're going to kind of link this along the way here. Our limbic system, which is obviously consisting of our amygdala, hypothalamus, hippocampus, and such. This controls behavior used in attack, defense, or retreat, such as the fight or flight response. And the amygdala has a certain role in emotion when we talk about the issue of fear. Not to say that it can't work with some other parts. For the most part, the amygdala, for the most part, is kind of one of those areas where it kind of receives messages, um, kind of from the quick and unconscious emotion processing pathways. Um, when we talk about the reticular formation, you got to think about the brainstem and such. It is the emotional reaction alarm for anger and fear. It kind of works with the thalamus and the amygdala to detect threats that set off the automatic responses. And needless to say, this again is kind of quick. It kind of does involve things that kind of revolve in a cascading of the autonomic responses that not only arouse the brain, but also makes our heart accelerate, hence kind of playing along with that fight or flight response that we mentioned before. The cerebral cortex, this is our thinking cap. It helps us with conscious emotion pathways. It interprets events, associating them with memories and feelings. And this is where we get into talking about issues of lateralization as far as emotions. Left hemisphere, for the most part, is involved in influencing positive emotions, for example, like happiness, whereas the right hemisphere has a tendency to influence negative emotions such as anger. The autonomic nervous system. We have the two divisions, the parasympathetic division, which dominates pleasant emotions. This is the part that kind of calms us down, and our sympathetic division that dominates unpleasant or startled emotions. This is when we're faced with a stress or something and our heart accelerates, and for the most part, we are preparing for a situation where we're going to have to be at full alert. And then finally, hormones, when we talk about the releasing of certain neurotransmitters, serotonin has a tendency to be linked with things like depression, epinephrine, fear, norepinephrine with anger, and then finally, steroid hormones can also influence things like our emotions. So, do our physical responses cause our emotions? So, we're going to talk about the psychological theories of emotion, and we're going to get into talking about the James Lange theory, Cannon-Bard theory, and then we'll take a look at the two-factor theory and a little bit about cognitive appraisal and opponent process theories. So the James Lange theory, this is attributed to William James, one of our founders of psychology, and Carl Lange, who happened to be a Dutch psychologist who, kind of weird, at the same time these men kind of came up with this theory, and hence they share the name of the theory, though they might not have really been working collaboratively to come up with this. So this is what the theory states. Emotion provoking stimulus produces a physical response that in turn produces an emotion. Okay, so if you look at the example down below here, so you might have the stimulus being a snake. The physiological response is, trembling, our heart rate accelerating, and hence we feel fear. Okay, so we feel sorry because we cry, angry because we strike, afraid because we tremble. And so you have the event, the arousal, the interpretation, hence the emotion. The Cannon-Bard theory, this is attributed to Walter Cannon and Philip Bard. This theory states for the most part that emotional feeling and internal response happen simultaneously. So, the emotional feeling and internal physical response, one is not the cause of the other. And hence, we might use a little bit of cognitive appraisal, which we'll talk about. But if you take a look below, if we have our same snake, the stimulus is the snake, and at the same time, we're trembling and feeling fear. And we can't tell which began first. We just assume it all happens at the same time. It is possible that you could be a person who sees the snake and then you think, oh, yes, it is a snake. I should be scared. And it might happen in that response as well. The two-factor theory, or sometimes known as the Structure-Singer theory, kind of attributed back to Stanley Schechter back in the 1970s. Emotions we feel depend on our appraisal of both our internal physical state and the external situation that we find ourselves in. So, method actors, people who might suffer test anxiety, any kind of emotion provoking stimulus. So, if we're going back to our fear, it could be the fact that we see the snake. We might have that physiological arousal, the trembling, increased heart rate. We might even say, I feel afraid. And then it hits us, we feel fear. It may just depend on the person and what an individual is being faced with and how they interpret it as far as how much fear they sustain. Cognitive appraisal theory. This is where individuals decide on the appropriate emotion following the event. After the event has occurred, we decide how we should feel. And so we might at some point in time really be thinking about, should I be angry? Should I be happy? Sometimes there are events that we do make a conscious decision on how we're going to feel about that. And then the opponent process, it kind of reminds me a little bit when we talk about sensation and we talk about theories of color vision, but emotions have pairs. So when one is triggered, the other is suppressed. So when we feel happy, sadness has a tendency to be suppressed. And in a weird way, when we're happy, if we're recalling memories, there's a tendency that we block out the sad memories and we can only think about the happy memories. Same goes when we're sad. When we're sad, and we're obviously locked into that feeling, we have a tendency to suppress happiness, and we have a tendency only to think of other events in our life that have been sad. All right, other theories. Maybe not necessarily talking about emotion, but maybe a little bit with motivation. There is something called the inverted U function, which has everything to do with motivation, kind of getting yourself pumped up. And in a way, we've talked about this in our intro class, and I'll explain what that theory was that we talked about previously. But the inverted U basically means this, that increased levels of arousal can motivate a person's performance, but too high or too low a level of arousal could drop the performance, and hence an individual might choke under pressure. So there can be a time when, for example, there are certain moments where we're not necessarily experiencing a very high level of motivation, and that might mean that we're going to hang out and veg on the sofa. There are some times when we are really pumped up, but we can get to the point where we get ourselves overly motivated to the point that maybe we're in a pressure situation, like trying to make that winning free throw in a basketball game, and we're so pumped up that when we kind of fire that shot off, we miss and we choke. So this theory, for the most part, it resembles an upside down U, and it suggests again that either too little or too much arousal can impair our performance. The optimal amount of arousal varies from task to task. There are some times that you really do need to be pumped up, and there are some tasks that you really don't need to be. Okay. This theory is one called the Yerkes-Dodson theory. So you may hear about it as the inverted U, but it's also sometimes known as the Yerkes-Dodson theory. And it's all about the level of arousal. If you were a sports psychologist, this is something that certainly is of greater interest to them. All right, sensation seekers. This goes back to Marvin Zuckerman's theory, this idea that individuals who have a biological need for higher levels of stimulation compared to others. And so we have those people out there that really like things that kind of, put them on the edge, like people who love rock climbing or skydiving, or if you're a person that loves going to an amusement park, riding those scary roller coasters. There are some people that have a need for that sensation, and that really kind of gets them all pumped up. And then there are others who really have no need for it whatsoever. All right. Thank you very much.